This is the whole point, right? Solving problems on the fly.
Thanks a lot, Mr. David, for being here. Next up, we have Mr. Luke Ellians, representing Venture Builder Programs. Mr. Luke is the founding managing partner of Singapore Deep Tech Alliance, which is an impact-driven deep tech venture builder that brings together entrepreneurs and technical talents to take advanced technologies to the market. As a business leader and entrepreneur, Luke has vast experience with innovation from inception to product launch and has guided hundreds of startups and corporate clients to growth and investment. Thank you, Mr. Luke. Now we have Mr. Leonard Tan, CEO and founder of Analytics. Their mission is to augment human intelligence through actionable insights powered by artificial intelligence. Mr. Leonard is a technology enthusiast and enjoys keeping up with latest technologies and news, especially in the field of AI. Thanks to all the panelists for being here and joining us for the industry panel discussions that shall begin soon.
Okay, thank you, Ahana. We can start now. So actually, we turned off, but the title is to look at how various stakeholders can come together to foster semiconductor industry 4.0. That's why we have representatives from different sectors, right? So firstly, I have a question to all of you. And I'll start with Vijay. The common question is that, what's your perspective about semiconductor industry 4.0 innovation landscape in Singapore? And Vijay, to you specifically, as one of the fastest growing semiconductor OEMs, how has COVID changed the game in general, in Singapore, globally? How do you think it has affected? Yeah.
Yeah, I think COVID has changed quite dramatically the working environment. I think first of all, the obvious one is the demand of work from home that fundamentally have driven more demand for semiconductor components and driven a larger part of what we see today in terms of the demand growth for chips and integrated chips. In addition to that, it also has created an environment where you hear about this great resignation throughout the world. Less and less people are working. The pool of workers are shrinking, which is creating this supply chain interruptions around the world. So food shortages, when you think about food shortages, we talk about food shortages, I think we're going to have chicken shortage in Singapore, and in the US, there's powder, milk powder, baby powder shortages, and more such things are happening. And you wonder why is this happening? And it's fundamentally because of the interruptions in the supply chain due to less and less people in the workforce. And that's now creating this challenge of, okay, what do we do next, right? So it's actually driving this COVID situation and now driving a faster and quicker transformation to automation and more integrated digitalization effort than I think before we had COVID. I think before COVID we always talk about it, we sort of had a plan, but now this is really driving very, very hard that we really need to do something to be able to solve the existing problem that we have. Especially for Singapore, I think the environment is good. A lot of these innovations can be lighthoused, we'll call it like in Singapore, and that's part of what we are doing. We are building prototypes and doing simulations out of Singapore so that eventually we can globalize the solution.
Yeah, okay. Thank you, Vijay. So, David, do you think semiconductor industry innovations is more in the academic and research institutes these days than it was before? Because semiconductor is always a demanding industry, but how has it changed?
So when I interact with the faculty members at NTU, we're not going to be competitive against TSMC, right? GF, I used to work in chartered semiconductor in the 1990s, so even Intel is not competitive against TSMC. Neither Samsung is probably on par. But Where we're looking at in terms of the research and direction of innovation is in alternative silicon technologies. For example, when you talk about Industry 4.0 and the transition towards EV, the accompanying electric power grid requirements, that transition to renewables, transition to DC transmission and generation creates a different set of problems. So that's in the domain of high power, either DC high power transmission or DC to DC. So this whole field in electrical engineering, where when I went to university, power electronics was a boring subject that no students wanted to even look at because it was so boring. It's now getting a revival because we now have a different set of problems. When I talk to faculty members in power electronics, it's a big and growing area. But the semiconductor industry right now probably is not equipped to do that kind of those kinds of devices, because in cars we're going into silicon carbide technology for 5G, 6G, 7G technologies that's going into high frequency technology. So high frequency potentially requires you to transition into compound semiconductors on silicon. So GaN on silicon technology is going to come up. But silicon carbide technology is also going to come up for high power. So these are some of the areas where you can see innovations, and in optoelectronics, as well as alternative, what we call spintronic devices. For example, ReRAM, MRAM technologies, low power, extremely low power devices for IoT applications. So these are some of the, what I call interesting areas. Now, if you look at compound semiconductors, there's very little supply out there for silicon carbide foundry services. So, we as Singapore have to look at, innovating or competing at scope and not competing at scale, because we cannot, we're not going to ever challenge TSMC from that perspective, but we have to look at niche areas where you potentially see an emerging class of devices or new power electronic requirements coming up. So then is there a space for Singapore to innovate at scope in some of these areas?
Thank you, David. I agree, and thank you so much for sharing actually the advancements, because you're within the ecosystem and you can share with the audience what is the next up-and-coming technology. Luke, my question to you is also the same, almost. You are Singapore Deep Tech Alliance, right? So how is Deep Tech impacting the Industry 4.0 space or semiconductor space? Like, I know you started recruiting your next cohort, so you kind of have a feel of it. What are the kind of technologies that you are able to scout or are entering into the SDTA Alliance?
Yeah, thank you. So I would say the reason why with Singapore Deep Tech Alliance we're focusing on building deep tech startups from scratch is, I think it has a lot to do with Singapore. Singapore by nature has an extremely strong ecosystem when it comes to doing R&D in deep tech. If you look at the investment going into this for many, many years already, if you look at the technologies lying on the shelf, if you look at the long-term vision that is necessary to make those sustained investments to then commercialize. So that's one reason why we very much focus on that. And I would say secondly, from our point of view at least, there is an extremely strong correlation between deep tech and sustainability. If you just look at a lot of data that's out there, 97% of deep tech companies by nature will have an impact on one or more of the UN Sustainable Development Goals. And this is important, I would say, for the governments, important for corporations, but it's also important for individuals to get involved more and more in that type of company creation, I would say. So for us, that's the reason why we focus so much on semiconductors. Singapore has the heritage there. Singapore has a sustained investment already for, I would say, more than 10 or 20 years to build up the R&D portfolio to be able to build companies. And then there's the correlation with sustainability. Now, if you look at particular technology areas, the things that we are quite interested in is, for example, photonics. It's a big area where we've been building companies before in Europe, and we see a lot of opportunities in that space, but also more upstream and downstream innovation. So, for example, what can you do with all the waste streams that are being generated nowadays by the semiconductor industry? Can you repurpose some of those resources? Can you do something with the wastewater? There's so many opportunities there. So we try to focus on those primarily.
Yeah, that's great. Thank you, Luke. And Leonard, I know all of us here are actually trying to support startups, like each one of us here, industry, academic, and also Singapore Deep Tech Alliance. But we wanted to hear it from you, actually. Are you feeling supported? Are you getting access to resources? Yeah?
Yes and no. Of course, I mean, just to be frank, right? I mean, I wouldn't say our experience has been a smooth one, but definitely there are good corporates out there, and some that maybe still have certain ways or steps to improve to run any kind of program or be it incubate startups, right? So personally, I do feel that when incubating, especially we're talking about deep tech startup, there's a lot more patience. It's not like consumer tech. You need to bring in the domain knowledge. You need to bring that to the table to the startups. You need to have a bit of patience. You need time to develop the solution. You can't expect the startup to have developed something. It might be in a very containerized, parameterized environment through research, right? But bringing out and productionizing something like that is very different. You are not aware to certain environmental conditions or even standard operating procedures of these large corporates, which you don't account for in your research. So our experience so far has been a bit mixed. So for some large corporates, just to get the ball rolling, we waited 5 months just to get an NDA, and I could have developed the solution in 1 month, right? So sometimes when working with corporates, I think speed is key. The startup for sure has the speed, but can the corporate match that speed, and can it remove the necessary red tapes, right, and bureaucracy and hurdles to really talk about innovation, work directly with the people on the ground and the teams on the line to develop products. But on the other hand, we do work with very supportive corporates as well, and also work together with, for example, ESG, MTI, to really come together and overcome some of these regulatory gaps, domain knowledge gaps, support in terms of funding as well. And when all these elements come together, we actually innovate really fast. We actually build products that make sense for the end users, for whoever are going to use it eventually, and maybe not some nice to show kind of thing, right? Because you don't want to waste the startup's time as well. You want to be really building valuable things that can eventually be used, not just because you want to show off. So I would, my kind of 2 cents, at least for corporates, is when working with startups, be lean, be agile, give the domain knowledge support, and understand that things take time. And for the startups, I would even say that don't try to be the be-all and end-all kind of solution, right? You might develop very good specific niches and that we can bring out from the research, but also have in mind the way to connect everything together. Because what I do see now is that a lot of startups might be very good at one thing, like for example, we are specialized in video analytics, but we know that we are just a cog in the wheel, right? But there's a larger ecosystem at play. We have to collaborate and work together with other startups and other divisions in the corporates to really bring the full solution together. Because otherwise we will end up with multiple silos again, with overlapping features and redundancy. That we might end up better, yes, but maybe we could be more efficient for sure.
Thanks, Leonard. And I know we can confidently say that we are that kind of corporate who is trying to remove those barriers. Within UCT, that's what we are striving to do. That's why we have LedLab, and we will try to expedite the process for the startups as much as possible so that you can fail fast and innovate faster. Yeah, thank you so much. And also to the audience, later we will open the floor for questions. So you can be ready with your questions to Vijay, UCT, David from Intuitive, SDTA, Luke from SDTA, and also Leonard from Analytics. It's an Industry 4.0 startup. So my next question, again, I'll just follow this order. So Vijay, we are a very big OEM, multi-billion-dollar OEM, and still you think we need to innovate. I know you're very passionate about innovation. I want to know why you think that innovation within UCT is a must.
Yeah, I mean, you always have to innovate, just like education, right? We never stop learning. You just continue, and especially in the industry, competition is always there. You need to always one step ahead, and to either to continue to expand your growth or continue to improve your bottom line. That's the bottom line of what corporations do. So that's part what drives the innovation. And there's sometimes when we talk about innovation, it falls back into leadership. Right? Either you innovate based on what you know today, or you innovate knowing where you want to go. Right? And I think this is going to be two very important elements. And for UCT, we know where we want to go, and we have a clear view of also in digitalization effort, and we know that without innovation, if you stand still, you know, hard for you to survive in the competitive environment. So innovation, that's why you need to continue to innovate.
Yeah, you're right, Vijay. And as much as I spoke within UCT, to our internal champions, I see that they share your passion too. They also feel that they need to innovate, and that's why they're open to talk to startups like that of Leonard's, right? So yeah, that's true. And David, one important question to any research or academic institute is, you have a lot of IPs and innovations within you, but how easy is it to license it out to a interested startup or to spin out the startup itself? What are you doing within Intuitive to make that, ease that burden? Yeah.
So we follow the American university system where all the IP is owned by the state or the university, so that was the Bayh-Dole Act. And we, from a philosophical standpoint, all IP has an expiry date to it. It sits on the shelf and it expires, unless you are a therapeutic or a compound that you've discovered that cures cancer. Generally, for any kind of non-biological or non-life sciences IP, there is a date of expiry stamped onto it. So, recognizing this, we try to get the IP out as quickly as possible. So our data shows that we have a last in, first out type of inventory management for our IP. That means that the IP that's filed in our office gets licensed out the fastest, and the longer it sits in our books, the more useless it gets, because either the researcher is left, the funding's cut, or they no longer are interested in the IP. But to answer your question, we remove as much of the friction as possible, and I think I can speak the same for our counterparts at SUTD and NUS as well, because philosophically, we just want to get the IP out. The cost of licensing is very low. We align ourselves to the startups by taking a small equity stake in the company. So we're playing the long game, so that we cannot realize value in the startup company until they exit, or the cap table is restructured by the venture capitalists, or there is an M&A opportunity. So that means that if we have an equity stake in our startup, we are somewhat compelled to help the startup raise the next funding round, or we may be talking to companies such as UCT, where potentially they articulate an interest in looking at some of our startups, or they have a problem statement where they have made it clear that they're looking for solutions. So then sometimes we may find a faculty member that will come up with a solution for UCT, or we may find a startup that already has a built-in solution for UCT. So we, in a way, are doing a bit of matchmaking. So there's upstream and downstream easy licensing, but post-licensing, we try and help our startups as well.
Oh, that's good, because we need to really give more access for the innovations to come out and impact, so that deep techs can have deep impact on the lives, right? So yeah, thank you so much for easing the access. And Luke, Singapore Deep Tech Alliance. You are the founding managing partner. What motivated you to found something like this when today the world is filled with a lot of incubators, accelerators, and even academic institutes like NUS and NTU they have? So how different are you? Okay, first, what motivated you, and how different are you?
Yeah, interesting question. So I would say when I sometimes explain to people in general, or let's say my mother what I do, people often tell me I'm a little bit crazy, because creating ventures from scratch It's one of the most risky things you can do. That's what we do. We literally incorporate the venture ourselves. It doesn't become more risky than that. And then we do that from technology. So with a technology first approach in deep tech, where the gestation period for the venture to go to maturity is much longer, while often the capital required to get it to a certain level of maturity is also much more. So it's probably the hardest thing you can do in venture creation in general. The reason why we started this, I think for us, is twofold. On the one hand, as I said in the previous answer, I am convinced that it is extremely important if we're building companies, if we're fostering innovation, we do that with sustainability at the heart. There is no other way. And that's one important reason for us to be in deep tech. Secondly, personally, I was involved in a deep tech venture builder who's also our equity shareholder in the Netherlands. So we have our heritage and our roots in deep tech. We have shareholders such as ASML in our venture builder in Europe. We've been building deep tech companies for a long time. We have a fund in Europe where ASML is one of the limited partners. So we have a lot of the ecosystem as well to support the creation of deep tech ventures. So that's kind of the reason why we started it. Now, to your second question, how do we do it, or how do we do it differently? So first and foremost, I think it's very important that parties like NTU build their own companies. So I in no way want to replace NTU. Actually, for me, this is also, it's totally not a zero-sum game. We should be building multiple ventures, as many ventures as possible, because the risk is so high. Rather build 100 ventures than build 50 ventures, and then hopefully some of them become successful. So our approach is, we take technology from research institutes, we bring founders into those technologies, and importantly, we try to build an alliance. Hence the name, Singapore Deep Tech Alliance. We have partnerships with parties like UCT to together come in very early and basically share risk. Share risk on the productization of the technology, share risk on the investment in the company, share risk in figuring out what the use case might be, share risk in figuring out the supply chain. So that's our approach. We are the integrator, I would say. We bring some of the technology from the research institute, and we have many corporate partners that we involve extremely early. I believe earlier this week I sent you a number of different technologies that we are looking at. Hopefully to involve you now already, so that we can together understand where the use cases and how can we build companies. And what we learned in the past, we have a portfolio of about 75 companies, deep tech companies that we built. If you do that, you can de-risk. If I look at our data of the companies that we built, about 25% are growing rapidly. We have made multiple exits already. And why is that the case? Because when we take technologies, we involve UCT. And who better to tell me if a technology has an application in the industry than UCT? Ideally, UCT comes in early in financing together some of the productization. And then we can take some of the risk. I'm fine to do that, but I want to do that with partners. So my conviction is that model is the only way to make innovation in deep tech work. You cannot do it in isolation. The risk is too high. We will fail. And then lastly, I do not have the illusion that a party like Singapore Deep Tech Alliance will be able to build companies that are at your core. You will execute your core R&D roadmap. You are much better than I ever will be at doing that. But there are opportunities around the fringe. As I mentioned, upstream and downstream. Opportunities which might not be core for your R&D department, but opportunities where I can build companies. So that's where we try to play. Maybe a bit more around rather than at the core of the foundries and the semiconductors.
Yeah, that's true. Thank you so much. Actually, it's also, you're making a point that we are all ecosystem enablers and not competitors to each other. The other day when I was meeting with a person from Micron Ventures, they share the same thing too. They are our end users, and they don't look at us as competitors, but instead they look at us as people who can co-invest and co-innovate. So we are all enablers here. Yeah, then Leonard, you are an NUS spin-out, okay, right? So what is the advantage of being a spin-out from a university ecosystem than being an independent startup? Okay, actually advantages and also challenges. I know Dorothy's here, but you can see.
So I'll start with the advantages first. Definitely, if you talk about deep tech, right, it's a bit counterintuitive in the sense you're not starting with a problem. Sometimes, research, research can start with a problem, but sometimes not necessarily the problem is big enough, maybe because of the particular way the research was set up. But you're starting with the tech first, and now you're trying to commercialize this tech, right? So yes, you do have the support. You might have funding. you would have worked with domain partners, you would have the opportunity to test bed even. But again, like what I mentioned earlier, you're in a very containerized, parameterized, clear environment with a set of specific goals and measurable KPIs that were done from the research, right? So for us, when we spin off, we run into the challenge part, which is basically, understanding the operating structure or the way companies operate, right? Because that adds element of uncertainty or even changes to the way the product needs to be designed, which we may not necessarily know in the research setting. Then, of course, you have the thing about price sensitivity. Is this a viable business? Yes, is the problem big enough? Can the startup survive just doing this? We have the startup itself has to kind of think on its own feet. How do we move on from here? How do we add complementary services? How do we build more products? How do we build more auxiliary services around this to become a viable business? Right. So I would say that these were kind of the two things that we were facing. Of course, it helps when regulators and companies, other startups in the space, we don't see them as competitors even. We see them as cooperators. For example, in regional, they are one of our co-operators, competitors / competitors in the space. But when you talk about deep tech, it's so new that even the end users might not really understand what the tech can do and what it's about, right? So the pie is really relatively big, and only if we work together as startups, we can educate the industry much quicker. We can help to provide more adoption in terms of offering or competitiveness, because competitiveness is healthy in our environment. It helps us foster innovation. If we are the only ones doing it, then sometimes we get complacent or we might think that this is enough, right? And I would say in our particular industry, there's only 2 or 3 of us, which is not enough. I do encourage a lot more companies to come into this sector for what we do specifically. But at the end of the day, I think that it's not that spin-offs are more difficult than starting from scratch. They each have their own set of challenges and problems, but I would say focus more on learning how to stand alone on your own 2 feet as a startup, and not just focus on doing what you did from the research, because it might not be enough to survive, right? I remember a very famous quote is sometimes saying that you don't want to build or understand how to make the horse go faster. You want to know how to build a car. So sometimes some research takes so many years to do that by the time it goes out, maybe there are much better alternatives already. Does it make sense to continue, or how do you pivot from there?
Thank you, Leonard. Audience, do you have any questions? Otherwise, it's so silent. You can ask any question. I know I prepared ahead, but please ask questions. Yes, there's also mic.
There's a mic?
Oh, yeah.
Okay, it's mandatory to ask questions.
Yeah, please ask questions.
Yeah.
This is on?
Yeah, it's on.
I'm just interested to know with regards to Industry 4.0.
Oh, sorry, whom are you directing the question to?
Oh,
We have Vijay from UCT, David from Intuitive,
okay, maybe.
you from
Yes.
SDPA.
Vijay, maybe,
Yeah.
yes. Because, I want to know, Singapore EDB uses Siri index. So, do you all use that to start a project for Industry 4.0?
What's the rates? Can you?
The smart industry, the Siri from the smart industry readiness index.
Oh.
It's a framework for Industry 4.0. So
Yeah.
whenever any project is going to start, you understand your business. Excuse me. Yeah, you understand your business and try to see how do you implement I 4.0 solutions using the Siri index. So I'm pretty new to this, so I just want to know whether you all can do it.
Yeah, that particular question, whether we use that, probably have to refer to whether Ashish or someone who can answer it. But generally, from an industry point of view, we look at applications. When we drive any innovation, whether it's because we tend to say Industry 4.0, but the breadth of the 4.0 is pretty big, right? It's from the automation to the digital thread, connecting all the different pieces together. The supply chain solution is pretty wide. So when we embark, we're looking at applications. How do we improve what we do today? And of course, we have collaboration with EDB. We continue to work with them to see how we could expand some of the activities that we're doing in Singapore. But especially for the initiatives we're doing, we look at applications. What is going to drive better innovation and better efficiency in our operations than using the framework to try to drive the other way around.
Thank you, Vijay. Any other question?
About sustainability, what is the biggest challenge that has to be overcome in order to make the industry more sustainable?
Sure, I think I'll direct it to Luke because he always mentions that sustainability is the heart of SDA. So yeah.
It's the million-dollar question, right? I would say fundamentally, and this is very difficult, but what needs to happen is the cost of not being sustainable globally needs to be factored into doing business. That's what needs to happen. That's super hard. That requires global coordination. That's the only way, in my view, where ultimately the needle will be moved at the speed at which we need to move it. And that involves things like a global carbon tax, for example. That involves things like globally agreed upon standards of how we measure carbon footprint of production in this particular case. So measuring that in a standardized fashion and potentially having certain incentives in place to lower that as we go along. I think that's what's necessary. This is extremely difficult though. My personal observation is that it is not for a lack of willingness on the part of entrepreneurs, on the part of individuals, on the part of companies, but the whole sustainability problem globally is a bit of a prison dilemma actually, in the sense that we all want to do it, but to do that, if you are the first mover as an individual, whether it's a company or even a country, you lose out. That's fundamentally, I think, the issue that we have with sustainability. So it's not easy, and that's my answer of what needs to happen. Having said all of that, there are, I think, a lot of positives to take hope from. And if you look at governments like Singapore, but also I think Europe at the moment is really kind of leading the way to drive sustainability in the way it needs to be driven. And I do believe companies like UCT, they're starting to mean it. And that means that there are long-term investment horizons to really make sustainable innovation happen. But it does require long-term investment horizons, and it does require very, very strong global collaboration between the public and private parties to ultimately make it happen.
Thank you so much, Luke. Yeah, my next question will be a follow-up on that. But before that, does anyone else have a question?
Anyone?
Okay, if not, I'll have my last round. Okay. Thank you. You can actually ask so many questions. Yeah, because after this is networking, just networking. So.
I'm Manish from India. My question is, historically corporates have had a lower risk appetite in terms of investing into startups. Are you seeing that risk appetite change? And maybe to learn from a startup viewpoint, how has your experience been in terms of access to capital?
Okay. Yeah, let Vijay answer the first part and then let it.
Yeah, I think as more and more people talk about 4.0 and the benefit of the 4.0, the interest and the investment being made is increasing. That's why I think the whole lab concept is really interesting if you think about it. Historically, how corporate you get engaged is you engage in available technology, right? So if you have a problem in your operations, you look at the problem and say, okay, what solutions are available for me to go and put in place to solve it, right? Now we're thinking thinking about how do we make the investment, put aside investment, we think about problems that we want to solve in the future. Right? So that switch in mindset is requires, plus the willingness to put that money aside that doesn't drive immediate benefit, is also very important. Right? So more and more of this is happening, and we do that, and this lab concept platform actually allows now to start identifying what are those technologies out there that potentially can be used internally. Maybe not now, but we could see it. We could see this application coming in the future, and it gives us a platform for us to start engaging and making an investment in a much more wiser way. So yeah, to answer your question, more and more corporations investing. We are also putting, increasing our investment. If you look at the last couple of years, we are significantly putting money aside for Industry 4.0. Not only for today's application, but also investing for the future.
I think that's a very good point. I also want to emphasize that we also have our own Industry 4.0 team, where we go look for ready-made solutions through the team, right? And that's where LED Lab is different from our existing team. As Vijay mentioned, we're looking at problems futuristic, and we're trying to develop technologies to those future problems. Yeah. And you can answer, Manish.
Okay, so just based on what I had, because we recently raised our seed rounds, right, and we talked to a couple of family offices, companies, and angels. What I feel is that for, let's say, VCs, right, you're talking about VCs, they normally have a very specific thought in mind. They have their fund cycles, they have their GPs and LPs that they want to make sure that they give a significant ROI to, unless they have a very specific fund mantra or philosophy to look at real deep tech. In general, I'm just talking in general, they normally look towards the more consumer tech on a whole, definitely, compared to the number of investors who will look at deep tech. Where I do think that corporates or investors do look at deep tech are companies like UCT and corporates that have a much longer horizon, or even like the Deep Tech Alliance. Because for deep tech, you definitely need much longer. I'm talking about some can go beyond 8 to 10 years, which is normally the fund cycle of VCs. And the pool, and I have many fellow co-founders that are really struggling at the moment. They have brilliant tech, but the risk and the number of investors out there at the moment it's so small. It's really, really very small for them to. So some of these don't even see the day of light. They die before they even get to try and live. That is kind of how I feel the landscape is at the moment. We are quite fortunate because we met someone who actually understood the problem that we are solving, and they understood that it takes time. But for us, it was angels, so they don't necessarily have a GP, LP to kind of report to or make sure that the ROIs are actually met in a certain time period. So, and now I think it's safe to say that a lot of these consumer tech, VC, the bubble is popping a bit, right? A lot of valuations are coming down, and I do hope that some of these make them realize that, okay, let's focus on real innovation and let's take a look at deep tech as well and focus on sustainability. I do hope that this is, some of this shift will happen in the coming years. But I would say the current climate, considering all that's going on in the world today, it's still tough for deep tech startups to really raise proper capital.
I have also a question for you, Ben. I'm holding the mic so I can jump in. As you mentioned, you raised funds. You already have paying customers and video analytics. And we talk with you, but not for the manufacturing area. And we talk with you, and eventually we would like to pilot and maybe use this technology in a different setting. Basically, this means that you would work out, you would need to pivot your product. Like, why are you doing it?
I think, different, I would say that for a startup, we need to be cautious about the resource. We have limited resource, we have limited time. And I would say that since we started from construction, manufacturing has a lot of the similar elements when it comes to safety or even productivity, right? We're talking about making sure the PPEs are there. We are doing defect checks, cracks, so on and so forth. Even productivity, looking at foreign objects or tracking objects throughout the manufacturing line. or tracking materials throughout the construction site as well. So it's a natural choice for us to enter, manufacturing next and work with you guys at UCT. But it's again, I think how the startup operates and how they foresee where they're going to bring their tech to. I think one of the challenge, or maybe one thing that founders can improve is sometimes they do so many things that they end up nowhere. They have a tech that is not good in anything but can do many things. So the startup still has to have some element of focus. They have to find their niche, and once they have their foothold there, and when they have a more stable kind of baseline, then they should start to explore other opportunities that are synergistically relevant. And I do think that UCT and what we have developed for construction is synergistically relevant.
So the way I get it correctly, we would help you do the focus to the manufacturing. You would better, like you mentioned in the beginning, would have a product market fit that is more core to the technology. Eventually, we're helping you, just like you're helping us, but we're helping you to focus and make sure that you're not wasting your time in developing a product that we can do.
Yeah, absolutely. I think when we work with you and work with your engineers and the team on the ground, you bring the domain expertise, and we start to develop something that is not only beneficial for UCT, but the semicon industry as a whole. And I think that is really important because sometimes startups or maybe even corporates are focusing too much on a particular problem that might only be for them, but they're not solving the real underlying problem. And we do hope to focus on those problems to really uplift the entire industry. But it's companies and corporates like you guys that help us enter new industries, new markets, and to help us grow as a company. So without partnership, it's very hard to do things by ourselves, even more so for deep tech startup. And I really appreciate the things that you guys are building here with Lab, and I'm pretty sure that was why Lab in Israel was so successful as well.
Thank you so much for the marketing. Thanks, Leonard. So before we go for the networking, which we believe that is much more important than all the talking. One question quickly to all of the panelists here. It's the same question. Or not maybe. What do you expect working together with UCT's Innovation Lab? That's a common question. But to Vijay, what kind of innovations do you expect that we should look for and bring into UCT's Innovation Lab?
Yeah, no, as I said, the Lab platform is exciting and interesting because of the different perspective of how you look at innovation and how you drive the innovation. From a corporations wise, and if you look at our operations of the business, it's pretty broad. So there's a lot of innovations we're looking for. You could go through a list of problems that we want to try to solve, whether it's from the supply chain. A simple thing is like we are a $2 to $3 billion company. That's about any point of time there's $1 billion worth of materials floating around the world. Just being able to track and see where they are, when they're going to arrive to the customer, how they're going to arrive to the customer. Simple problem like this is a very complicated solution today, right? So there's quite a broad applications that we're looking from an end-to-end supply chain perspective, and that's why if you look at a company like this, there's many teams are working at a different part of the supply chain, trying to find the right solution to continue to make us look better, to do better and innovate better. So it's very hard for me to specifically pick on one because there's so many things. Of course, one of the things that we are actively doing right now is creating a connected ecosystem for automation. Right? When people talk about 4.0, sometimes people just think it's just automation. But for us, it's how do we get a connected automation where automated equipment can able to interact with another automated equipment and create a much better efficiency than you can do without it. So that's one of the main focus we have in Singapore today, driving automation and connected automation that we can proliferate around globally to all our sites.
Sure, thank you, Vijay. We're also working very closely with all the regional champions, many of them who are present here, to look for problems and bring relevant solutions to UCT. So David, it's the same question, but in a slightly different way. How can we, UCT and Intuitive, or in general any academic or research institute, how can we work together to co-create ventures? What are the ways in which we can work together?
analysis of all the spin-off companies that we create, 9 out of 10 companies in our portfolio fail because of the business model, not because of the tech. So the tech can be pivoted, but it is the lack of a proper business model, the lack of a scalable solution that appeals to a global market. Because the challenge is that in Singapore, the market really is small. We're a 5 million population. The other challenge is that most R&D centers are not in Singapore. So if I'm a deep tech company, most of the time I need to interact with R&D headquarters. That R&D headquarters could be in California, it could be in Texas, it could be in Berlin, or it could be in France, you know? And so if I need to do, as an engineering startup, to do what you call spec-in, right? I need to go and figure out who's the R&D CTO in France, right? And if I can't find that person, I'm kind of swimming around randomly, you know, navigating the corporate hierarchy to find out who's going to be not the champion of this technology, but the decision maker of procuring the solution that I made. And that's one of the challenges. And so, if UCT were in Singapore and were doing some basic R&D, we would then go in and have a conversation with UCT, visit your manufacturing location, talk to the head of product or head of manufacturing and say, hey look, what problem sets do you have? And we get these inbound inquiries from companies sometimes because more and more global companies are also realizing we don't know what we don't know, but we're going to put up tech scouting activities globally in cities or in centers where there are key, where the research ranking of the universities is high. So for pharma, that's already an established practice. Pharma companies do not do basic R&D. They co-create with, you know, AstraZeneca with Oxford University, or you co-create with a biotech company. So in order for us to do a better job of creating fundable startups, we need to ideate on the business model. In order to create that business model, we then have to work very early stage with the scientists and say, look, you got good science, but you know, we then have to figure out, okay, go to the company, go to UCT and say, you have a problem here, potentially we might have a scientific solution ready. But then you have to go in and look at the engineering. How do you scale the science into a spec-in product? You know, that's an engineering problem. So science is non-deterministic, engineering is deterministic. You need the spec-in. You need UCT to define the use case and the spec, you know. So from there on, then we have to wrap the business model around it. And that business model is very, that business model we create, because I come from not just an engineering background, but I have finance as well and fund management. So I then, the mantra or the mission given to our team is, I want you to create investable companies. I don't want you to create companies per se, but they must be investable. So, because if they're not investable, they don't get capital to grow. And if they don't get capital to grow, then they die before they can even go out, right? So, part of what we try to do then is say, okay, idea on the business model and say UCT has this problem. If UCT has this problem, does Applied Material have this problem? Does Novellus, KLA, Tenco have this problem? So if they all collectively have this problem, then we're solving an industry problem. And we're not solving a problem for one company that's a teeny tiny segment of the market. So that ideation on business model is very critical because VCs will look at it. Are you solving a local problem? Are you solving a company problem? Or are you solving a global problem? And they only want to fund global problems. They don't want to fund a tiny, you know, problem that's specific to one customer.
Right, and that's exactly why we want to build an ecosystem, so that you are not useful only for UCT but also to the customers and the end users, right? Thank you so much. Luke, so we are already we started to work together. How can we be beyond a corporate sponsor or beyond, what can we do more than being a corporate sponsor or a problem statement provider? Yeah, you can let us know in the stage so that we can prepare ourselves. Yeah.
Right. I'll answer the question, but I quickly want to make use of to come back to the deep tech venture capital situation. I just want to say I very much feel your pain. We had a situation last week where we have a company that we invested in that has a 5-year R&D trajectory behind it with extremely interesting technology. where we had to do a bridge financing of a couple of months because no VC wanted to come in, even though the technology is very interesting. And the main reason the venture capitalists did not want to come in is because the company doesn't have any revenue yet, but that's kind of part of building this type of company. And now we are on the verge of announcing a multi-million investment there. So we will solve that, but I think it's a very real problem. It's essential to be solved. I think what's important, besides everything you mentioned, I couldn't agree more, is two other things. First, one of the reasons why VCs find it difficult to invest in deep tech is because they don't understand deep tech. VCs do due diligence on companies. They understand business models, they understand financial models, they might understand how an e-commerce business model works. They don't understand deep tech. So I think one of the key things that needs to happen, more people in deep tech, maybe in this room, should go into venture capital. Ideally, I would hope that there are some partners that work in semiconductor that make this jump, so that people can actually make the assessment. So that's one. I think that's extremely important. And then secondly, and luckily in Singapore that's happening, for the early stage, the government has to come in. Because the risk is too high, there's too much capital, so you need to share risk. I think that's already going in the right direction, but particularly for the first point, I just want to highlight that. Now, to your question. I would have two hopes for our collaboration together. Obviously, over the next 5 years, we are hopefully going to do a lot of POCs, pilots, technology explorations, venture creation together. That's great. My two hopes would be that we are successful together at creating a company that makes UCT so excited that you come in as an investor. And then my hope associated with that is that in the next 5 years, at some moment in time, somewhere in the world, we are raising a big gong. Maybe not in the next 5 years, but let's say in the next 10, and we pop the champagne together. So that would be my hope.
So we can definitely share your hope. Thanks, Luke. Last question before we wind up. Leonard, share some use case. I know you already made me, but you can share just two specific use cases for UCT or for any OEM in general in the semiconductor space.
Yeah, I would say the first thing, I believe one of the most important thing is actually quality or defect checks. But quality or defect checks, checking for cracks, scratches, dirt, foreign objects, and things like that. There's a wide range of things, but quality shouldn't be an afterthought. Quality shouldn't be only when the product is at its late stages. Quality should be built into the process. So all the way from design to manufacturing in the final product. I think video analytics and combined together with AR, VR, or even IoT sensors can help with the quality control checks all along the way for these kind of things. And the second thing is really, I would say the next use case is also on efficiency. Where are the bottlenecks in the manufacturing plant where maybe things can be shifted around? We can look at heat maps of certain way things are positioned or certain way that the manufacturing line is designed. And I would say all this ultimately contributes to better efficiency, operational kind of performance increase as a whole. But I would say if I can add one more, would actually be on the safety aspect. Because sometimes companies might think that safety is, okay, we have a decent amount of safety, but maybe we don't need to go more. But actually, if you think about it, if you have very good safety protocols in place and ensure that with the assistance of technology, you can actually indirectly improve productivity and efficiency as well. Because maybe you have less workers who are fatigued. Maybe the way that we are looking at how they carry items, I know the ergonomics and their human posture is correct. We can prevent downtime. You can prevent any kind of sickness, even if let's say safety policies are in place, or injuries or prevent injuries, right? Ultimately, it also all contributes back to efficiency. And if you go back in time, maybe we start with digitalization, then we go into automation, and then next is how do we improve the efficiency, right? Automation does improve efficiency, but sometimes you want to make sure that you're automating the right things, and you're automating in a way that it not only results in just transfer of responsibility to some other people or department or device, but you actually want to look at it as a whole that is improving the entire process.
Thank you. before we close, yes, someone can pass the mic. You have the mic.
I'm Thiru from NTT. Some of them partially answered my question. I need a more elaborative answer. Now 5G, 4.0, there's a high, so much volume of data being generated. There's no contextual information because OEMs, automation companies, they don't have any standard data. Considering the future AI models, the AI models need quality of data. So is there anything done to standardize sticking to certain framework so that the AI can be meaningful? Otherwise, garbage in, garbage out, right? So is there anything, this is more to Vijay, because he takes something. So do you have any thoughts? Is the industry moving in that direction? Thank you.
Yeah, especially for standardization, I do not know. Of course, when you talk about AI, the programming language, I think there's from a corporation-wise, you want to try to standardize within your company to make sure that as you're introducing more and more of this kind of stuff, there's a bit of standard platform you generate. So that's something that you want to do. But whether there's an industry standard, I do not know. And whether there's a need for it, I also do not know. But obviously, within the corporation, you need to have some kind of standardization because one of the key things for us when we talk about Industry 4.0 is the connectivity. The connectivity is very going to be very critical as we start doing more and more automation and more digitalization. So for you to achieve that connectivity, you need to create some kind of standardization in the language and the protocols between the different applications. So internally, I can see that we have to drive it. That's part of what we drive, trying to drive standardization within the company. But I hope maybe that will drive standardization across when more companies start doing this. The companies that's providing those kind of services will start thinking about standardization too. But we also, the application is so wide. Just think about some of the things that we are doing from an ERP system, right? So SAP or Oracle is an ERP system, and there's many applications like manufacturing, MES, the shop floor system. The protocol, what we dictate is we want the MES to be able to interact with SAP. So these companies have started to create the right protocol, so there's a communication between the different systems and different applications. So that part is being driven standardized. So more companies are coming out where the particular applications already have a standard protocol established for communication between the different applications. But those applies where you have the bigger applications like SAP and so on. So I can see that compared to a couple of years ago, you see more and more plug and play of this kind of applications because they standardize the communication protocol. And then internally with the corporations, you create your own protocol because you are driving internal applications and communication between your tool to tool or software to software, right? You create protocol. Yeah. So I don't really answer your question, but I can see more standardization from a communication protocol, because for you to do Industry 4.0, you need to have eventually what we call connected ecosystem, a digital thread, right? You need to have a digital thread between the different applications to be able to achieve the maximum efficiency out of 4.0. So that we could see that more and more companies and more applications, having that standard protocol. But internally, with your corporations, you need to drive your own standardization too.
Thank you.
If you don't mind, maybe I can chime in a bit on this one as well, because I think that's quite just to answer your question. We started in the construction space, and I think one of the things, especially for AI, right, it's a chicken and egg. You need the data, the companies need the data to develop the AI. And what is really working in the construction space is that the government, the main regulatory bodies, for example, JTC, HDB in Singapore, they are actually collecting data sets from all the different vendors to be given to all the vendors. Right? This largely accelerates the development of any AI application for the industry, which is something that I think we really need to see, because for example, if I were today to develop a new personal protective equipment model, I will have to first collect data sets from you, and then maybe company X collects data sets from another company, and you are wasting time and resources to develop the same use case, and you multiply by the number of companies that are actually doing the same thing. It's just a waste of resources. So I think there needs to be some form of government intervention with the support of the corporates to be able to share data in a way that it doesn't infringe on any security or privacy, which is possible, and make this open source or even available to companies to innovate on them and really accelerate the whole thing as a whole. So I do encourage the semicon industry and companies to be part of this kind of initiative to push things forward.
Thank you, Leonard. Any other question? Okay. If not, okay. Sorry.
Hi. Sorry, I would like to ask, opinion from you that in my previous job of working with government agencies in framing the policy for encouraging startup into countries, my experience is that as you work more and more with government, you realize that most of the policies or the financial structures are pretty similar, right? The closer it is would be Malaysia. I work with Malaysia government in Magic, and then I work with EDB. I would say that it's pretty similar. So one question that I have is that where do you see for Singapore, especially, how do we win in terms of getting more startups into the country? That's the first question. Or what do you think that we should do more, or what is lacking in Singapore that you feel that we need to add in order to get more credible startup into the country? That's one. The second question I have is that I like what David mentioned about we need to do something on scope rather than on scale. And I believe that for semiconductor-wise, from my experience, we sort of know what scope we want to focus on in the semiconductor space. But in terms of startup space in general for Singapore, do you see that we have formed some form of a frame of thinking of what type of startup we want to have in Singapore? So this is the two questions I have.
So Kai, whom is your first question to?
Oh, it's just a general. I just maybe on the gentleman that has sorry, I just
I think it's better if Len Wong himself answers.
Yeah, no, thanks for that question. Yeah, Ling Wan from Enterprise Singapore. So I think we work with many startups to try to promote startups into Singapore. I think in terms of your question in terms of do we want to attract more startups into Singapore? I think we definitely want to. I mean, how can we do better in it? I think it would be no different in many other countries. I think talent is one key issue. I think whether we can attract more talent here, right? Who will be interested to actually do the startups as well as I think the startups do recruit. That's one issue. Funding capital is an issue, and I think today, as what Leonard has shared, I think there might be stereotypes in terms of where I think venture capitalists, the funds are focused on, and how can we do more to promote in certain areas which are aligned in our, I would say, national interests, right? So I think even within the Singapore government, I think we fund quite a lot in terms of, I would say, certain focus areas. I think it has been shared before in terms of the RE framework, in terms of what our focus areas are, and we constantly review that. But these are also deep tech areas, right, for which I think I would say private sector funding is not as readily forthcoming as possible. So that is definitely an area that I think we need to do more. Yeah, so talent and I would say funding.
So yeah. I guess UCT is on the right direction of having an innovation venture, so to speak.
Yes, definitely.
To sort of encourage more startups into the fold. Okay.
Yep.
Thank you. And who do you want your second question to be answered? David?
Maybe David on the scope slide. The question is do we have a scope in terms of what type of startups we want to get into the country?
I don't dictate national policy. So we work closely with the funding agencies, EDB, ESG. But okay, so let's say, Singapore fundamentally is challenged by lack of land. Our property is nuts. Okay, our cost of doing business in Singapore is very high. And so we will never be a lot. So for example, for some industries, we can never be a hub for Toyota to manufacture cars here. So that means that you need businesses where land costs and property rents are not going to be significant. So where do you look at? You can't build a gigantic fab like TSMC has in Hsinchu Science Park. But then you say, okay, with all these new R&D stuff going on in optoelectronics, photonics, advanced materials for new semiconductor type devices. So for example, let's start on silicon carbide. If you can have potentially, let's say, a silicon carbide fab foundry in Singapore where you don't have such services elsewhere, then you start with that and say, okay, I now can provide silicon carbide foundry services. I don't need cutting edge technology at 10 nanometers. Okay, I can do it at 250 nanometers or 25 microns. Okay, so if you do it at that stage, because you're not driven by line width, you're driven by a different spec, which is I need high power now and I need silicon carbide as a material. So then if you have the foundry services, then you start from where TSMC started in the 1990s, where I create the foundry services, then can I have now the multiplier effects where I start fabless IC companies to do innovation around new chip designs that go into high power devices, right? Or high frequency devices. So it's almost like starting from the cycle from 1990s, but with an alternative material rather than silicon, because you cannot compete with TSMC in FinFET or 3D chip structures or gate-all-around structures, because we're just not there, you know. But can you say, okay, does TSMC have foundry services in silicon carbide or GaN? They don't. So can we do something around there? Possibly, because we don't need a fab for silicon carbide running at 30,000 wafers per month, right? Because that's the standard now for the new fab. That's going to cost a few billion dollars. But the mask set that goes into a lot of the cutting edge designs also, you know, for a startup, it's impossible for me to start a fabless IC design company today on silicon that's running at 5 nanometer technology, because the mask set itself is already crazy. It's like 20 million for a mask set, right? So if then I go to an alternative material like silicon carbide or GaN or you know, spintronics related, then I'm resetting the game and saying, okay, I'm not competing against TSMC now. I'm competing on a different material now, and I'm starting now at maybe I just need a foundry capacity of 5,000 wafers a month. Right? That's good enough because the volume is not there yet, but you got to start. So you start there, then you build the multiplier effects out by creating fabless IC design companies and potentially downstream component companies that make use of these types of components. Right? So that's, you know, and the other area that's really interesting is in 3D printing. Right? So I think that 3D printing is fascinating because you can shall we say, unlike typical manufacturing where you have scaling issues that relate to the variability of production caused by tooling equipment. So if let's say I want to put on a new dielectric material on the semiconductor device, you know, when I worked in Chartered Semicon decades ago, you know, we had a problem where we ran the recipe through an applied materials thin film deposition equipment. We ran it through a Novellus, and we ran it through a Tokyo Electron deposition equipment. So to create that, the electrical properties of that thin film, you know, shockingly, only one piece of equipment from applied materials worked. We would try it over and over again, and you know, from a fab manager operation standpoint, the worst nightmare is to have only one tool from applied materials that can produce that thin film dielectric material. Nobody wants that because that creates an operational bottleneck, right? Ideally, I want to be able to run that thin film through an applied or Tokyo Electron or through a Novellus deposition equipment. So, but then we try, and you know, we hauled in the equipment engineer from applied. We hauled in the equipment engineer from, you know, Novellus and then Tokyo Electron. none of them could troubleshoot and figure out, even though we program the machine similarly for all three equipment, that that's a plasma issue. So you don't know whether it's an equipment problem, you don't know whether it's an equipment engineering problem or process problem. So, three sets of different problems multiplied to the power of 3 equals 9 different variable combinations where you are, as an engineer, trying to troubleshoot and you can't figure it out. So then, for 3D printing, ironically, it's different. So if let's say I can produce a part from a 3D printer, I've locked in the process, I've locked in the equipment, and then I can cookie cutter and scale that by producing more equipment because the process is tied into that special equipment that I'm using. So I reduce the friction from scaling by using 3D printing. Okay, so that's the fascinating part about 3D. Other than that, the fundamental issue, the fundamental innovation for 3D printing is in materials. So you create a lot of IP for 3D printing in materials because if you have that special process or recipe to create that innovative alloy or composite or multi-matrix material, nobody else can do it. But that IP is your special secret sauce, superpower, right? So we can take this offline, but there's many areas where you can play, and that's the beauty about deep tech is that we are now, I would say in the next 10, 20 years, governments worldwide will embark on what I call the equivalent of the Manhattan Project to solve climate change. Okay, they are going to kitchen sink this problem, right? This Russian-Ukrainian crisis has also showed that we now have a food security problem, we have supply chain problem, we have a decarbonization problem. So all these challenges can only be solved, as Luke said, by deep tech innovation. You can't write code to solve these problems. Okay? So a problem per our definition equals a business opportunity. So you can see that the business opportunities are going to be significant in the next 2 decades, right? The question is, do we have the substrate and the fertilizer to put on this to grow the necessary companies to take advantage of that? I would say that in Singapore, per the research that's being spent in NTU, NUS, and A-Star, I would say that there is good substrate. The question is the translation, and the other question is the scaling, because Singapore is a tiny market. We don't build solutions just for Singapore. That would not be a VC fundable business. Okay? So thanks.
That's right. Thank you so much, David. Because we are running so much over time already, and my MC is missing. But so yeah, I request. Okay, she came. So we are done with the panel discussion, and I request the panelists to go back. I just realized that you don't have water, so just please go back to your seat and have some water. Thank you so much.
That was an extremely insightful discussion, and we're delighted to hear such wonderful visions and ideas from our esteemed panelists regarding Industry 4.0. Now, may I have Mr. Admon on stage for the closing remarks?
Thank you so much. I'm going to make it short because all of you said very nicely. I want to thank Viveka, thank you so much for organizing this so fast, and the entire team. Obviously, I want to thank also our guests and the panelists and everybody who came here today. As I mentioned in the beginning, we have here a very diverse set of people from a variety of areas. And from students for Industry 4.0 to implementers of Industry 4.0, be active in the networking. That's it. Thank you so much.
Thanks a lot, Admon. We hope the audience had a wonderful time. Now comes the most exciting part, networking. I would request all the guests to please proceed ahead to the foyer for networking over a fine selection of canapé and drinks. Thank you so much.